Hi, I'm David Coolis, sales engineer with Hafley Hypertronics. Today I'm back with the 5250 series portable primary cable fault locator to demonstrate how to operate the unit in advanced mode. Before we begin, we'd like to stress the importance of safety. Please use the appropriate personal protective equipment when testing with high voltage. Also, please follow the particular safety guidelines as outlined by your company. If you have not operated the 5250 in basic mode, I recommend following the link below to our 5250 basic mode demonstration.
Before initiating any test, make sure to check your connections to the ground, high voltage, and return leads.
Let's start by powering on the 5250. First, let's switch the power on, and next we'll make sure that the unit is in TDR mode. And then we'll open up the TDR case and then power on the TDR. Once the TDR is powered on, we can begin operating the unit in advanced mode. First, press advanced mode. If your 5250 is password protected, enter the password. If not, press OK. Next, the TDR will display the advanced mode menu options. From left to right, we have measure, memory, setup, adjust, configure, and basic mode. Pressing basic mode will take you back to the basic mode menu. To start the cable fault locating sequence in advanced mode, we want to start by pressing measure. Upon pressing measure, a new set of options will be displayed upon the bottom of the TDR. From left to right, we have sample, zoom, position, cursors, TDR, and main menu to get back to the advanced mode main menu. To start the test, we'll hit sample. We'll also notice that our TDR is selected as well, meaning it will send a low voltage impulse through the cable seeking impedance changes, and it will display those particular impedance changes on the screen. Unlike in basic mode, in advanced mode, you'll have to adjust the cursors, such as the end cursor and the fault cursor, manually. So we'll hit cursor. We will not want to touch the start cursor, as we had set up the hookup point previously. We do not want to adjust that. So we'll hit the button again, adjust the end cursor, and scroll it out using the red rotary knob to where the green line, which indicates the low voltage TDR, where the positive inflection, which signifies an open, and we'll scroll that out to where the beginning of that, because that will signify the end of the length of our cable run, which is displayed on the screen here under length. Next, we'll press TDR, which will give us a new set of options for the cable fault locating test sequence. Next is arc reflection. Arc reflection will send a high voltage impulse through the cable, and it will show a red line on the screen, and it will signify where the short is or the cable fault on the particular cable path. So once we are in arc reflection, we'll press capture. Now our high voltage options will be displayed on the screen here: fire, auto fire, high pot, off, and main menu to go back to the measure sample. At this point, we can adjust our test voltage either up or down in 500 volt increments. So we'll test at 6 kV, and again, we're in arc reflection, so we want one impulse through the cable. We'll press fire. The unit will begin charging, and then it'll discharge once it reaches the voltage. And as described, we'll see a red line signifying the high voltage impulse through the cable, and we'll also notice that there is a negative inflection, which will signify a short on the particular cable path on the TDR. So we'll hit main menu to go back to our measurement options. We'll adjust our cursors. Again, we've already set the start cursor with the hookup point, and we've also set the end cursor when we did the low voltage TDR. So now we'll set the fault cursor, which is signified with a black line and a lightning bolt. So we'll scroll that out using the red rotary knob to the beginning of the negative inflection. That will be approximately where our cable fault is. At 125 feet, the TDR will display the distance from the start of the cable and also from the end of that particular cable as well. Other options that you can do in this particular mode, you can zoom in on the cable in the X, which will shrink it down or expand it, You can also press zoom again, which will allow you to zoom in and out in the Y direction and increase the size of the trace. We can also delete the trace as well by pressing delete. You won't want to do that right now. So we'll go back to arc reflection, and at this point we'll begin listening for the fault. So we'll hit capture. We can test our test voltage. We'll go to 7 kV this time, and now to put the unit into cycle mode where it will automatically discharge or charge and discharge repetitively, we'll press auto fire. Now the unit will begin charging and discharging. And at this point, the other member of the troubleshooting team will be listening for the fault while one user is operating the 5250 here. The test can be stopped by hitting off. It can also be restarted again by hitting auto fire. And we can also manually stop the high voltage by engaging the emergency stop on the unit. Now I will give you an overview of some of the basic settings and configurations that can be made to the 5250. By pressing configure mode, you can go into the configurations that can be adjusted, such as the time and date, length of units, whether it's feet or meters or yards, the setup mode for when the TDR starts in either basic mode or advanced mode. The shots per measurement should be 1. The thumper type can be selected as well. Language would be English. The remaining configurations do not have to be changed. If they do happen to be changed, they can be reset by pressing defaults, which will reload the pre-installed factory defaults. Next are the settings in the setup menu. First is test type. It's either single phase or 3-phase. Next is velocity of propagation, which is preset at 250 feet per microseconds. It can be adjusted depending on the type of cable. Sample rate adjusts the speed of capture of the measurement system and should be preset at 100 megahertz. Pulse width allows the user to select the pulse width to be used on the system for measuring the fault position. Averaging sets how many data captures are performed for each trace drawing. This is normally set to 1. Trigger delay sets how long the data capture system waits in arc reflect mode after the thumper has been fired before starting the data acquisition process. Background allows the color scheme used by the system to be set. It is either black or white. And then next we can go to memory, where we can store the traces that we did using the TDR. We can also delete them, move them around, recall them to pull them up and display them on the screen, and scroll through each particular trace that has been stored on the TDR.
To recap, connect the 5250 to the cable under test. Next, power on the capacitive discharge portion of the unit and power on the TDR. Initiate the cable fault prelocating test sequence by pressing measure. Begin listening for the thump at the TDR's predetermined distance. And finally, power off the 5250 and unearth the cable to repair the cable.
Now that concludes the demonstration for how to operate the 5250 in advanced mode. Please visit our website for more videos and to download datasheets. Or for more information, please contact us at the number below. Thank you for watching.